When we're growing up, we tend to be pretty credulous. We just believe almost anything that people tell us, especially authorities and adults and textbooks and politicians and television, YouTube, the internet. I mean, there's just this sort of sea of information coming at us. And how can you tell the difference between, it's right or it's wrong? How do you know? People believe weird things because our brains are wired up to find meaningful patterns. You think if you see the face in the cloud or the face on Mars or the Virgin Mary in a grilled cheese sandwich or on the side of a window, many patterns are real, and it's good to know what those patterns are, and that's called learning. We connect A to B, and often A really is connected to B. Problem is, a lot of patterns are false. They're superstitious thinking. They aren't real. Well, I'm often asked when I give talks, why should we believe you skeptics? And my answer is, you shouldn't. You shouldn't believe anybody based on authority or whatever position they might have. You should check it out yourself. And we call this generally our baloney detection kit, sort of inspired by Carl Sagan's idea that there's a lot of baloney out there and we need a kit to detect it. And that kit is called science, and that's what science does best. So the first of our baloney detection questions you should always ask when you hear somebody make a claim is, how reliable is the source of the claim? You do expect some errors to creep into data, of course, but the errors should be scattershot. They're random. This way, this way, this way, this way. The errors are here and there, and they kind of cancel each other out. If the errors are all in one direction, slanting toward a particular belief, then that makes us suspicious that there's something else going on. Like the global warming skeptics, for example, will often pick and choose data that always slants toward that particular belief, or their errors always slant toward skepticism about global warming, and that tells us there's something else going on there. So a second question to ask is, does the source often make similar type claims? For example, New Age people, the people that believe in spirituality and ghosts and haunted houses and UFOs and all this, they believe the whole thing. They tend to be more susceptible to magical thinking, or maybe they're heretics just for the sake of heresy. Rather than following the data to see if that is a heretical idea that's going to overturn the mainstream, maybe. Usually that doesn't happen, though. The point here is you want to have a mind open enough to accept radical new ideas, but not so open that your brains fall out. So the third point in our baloney detection kit is, have the claims been verified by somebody else? You make a bold claim, somebody else has to be able to go out and test it. So the classic case study on this is 1989 cold fusion claim. Pons and Fleischmann hold a press conference. They announce, look, we can produce fusion in a jar on a desktop. This will solve our energy crisis. This will be energy too cheap to meter. This will change the world. Everybody was all excited. It was in the headlines, front page news, the whole thing. Until people went out and tried to replicate their experiment, and nobody could do it. So that told us right away, okay, there's something else going on here. It's a byproduct or an artifact. It's a chemical reaction. It's something other than what they claimed it was. So when you make a claim, if you don't have the data that other people can then go to their labs and run the experiment just like you did, if they can't get the same results, there's something wrong there. And in science, we require that. So our fourth point in our baloney detection kit is to ask, does this really fit with the way the world works? When you get one of those emails about the Nigerian, inheritance of $20 million, if you'll just send your money to them and then they'll send you the big pile of money, really, come on, is that really the way the world works? I mean, a pile of money for nothing? Probably not. For example, in archaeology, we often hear about, the pyramids, the mystery of the pyramids. Who built the pyramids? The Egyptians built them. Oh no, they couldn't have built them, because, wow, they're incredibly complex and so on. Well, it's just a pile of rocks, right? I mean, they had a lot of free time, a lot of cheap labor, never rains, centuries to build these big pile of rocks. Come on, it's not that complicated. But even if it were true that somebody else built the pyramid, say maybe 20,000 years ago, this is one theory. Maybe the lost continent of Atlantis and the Atlanteans came over there and built the pyramids. If that were true, when you do the archaeological dig, you should find the tools, the trash, the junk of the people who lived there, the houses where they lived, and that is what you find, dated at the time of the Egyptians. So if it was the aliens or the Atlanteans or whatever, you would find other artifacts to support that. So our fifth question you always want to ask, has anyone tried to falsify this or disprove the claim? In other words, it's one thing to pile up a bunch of evidence, go, look, I have this radical new idea, here's my arguments in support of it. Okay, interesting, but what are the counter arguments? Have you thought about that? Have you thought, what else could be explaining this? Because if you don't do it, somebody else will, usually with great glee, in a published public forum. You really have to kind of think about what your critics would say, not because you care about your critics, but because they may find something you're not thinking of. So you got to think along those lines. Try to disprove your claim. So our sixth point in our baloney detection kit is to ask where the preponderance of evidence points to, this theory or some other theory. Anybody can make a claim and then pile up a few points in favor of it. The question is what about all the other evidence? Is it also leaning toward this, or is it leaning toward that other theory that you're trying to challenge? So at all times, like in the theory of evolution, for example, creationists will say, well, just, what about this one little thing here? Well, okay, maybe there's a few gaps, or we can't explain this or that. But what about the 10,000 other pieces of evidence that are explained by the theory of evolution? How would you explain those with your other theory? In a way, science is a little bit like solving a crime. The guy never confesses, right? So you have to piece together the evidence that's available. And is it this guy, or is it that guy, or did this happen or that happen? And the way criminologists work is they try to kind of look at the mass of data and go, you know what? It's all kind of pointing that guy did it. And let's see if we can build our case. And that's a little bit how scientists work. There's always other ideas. The question is, what's the one that the preponderance of evidence points to?